Now, before we move forward in Azure Data Fundamentals, we have to focus on our module number 1, which is exploring core data concepts. There are various data concepts which you need to understand and you need to use in the cloud data. And that's what we are going to focus in this module. This module focuses on 5 lessons actually. The first lesson is going to explore the core data concepts. The second one is going to focus on roles and responsibilities in the world of data. Obviously, if you are a database administrator or you are a data analyst or data engineer, the way you're going to deal with data is going to be different. The lesson 3 is going to focus on describe concepts of relational data, and lesson 4 is going to focus on concepts of non-relational data. Same way, at the end of this module, we are also going to focus on the concept of data analytics, and then we can see the various types of analytics which we can try with data. In this video, we are going to focus on explore core data concepts. This lesson is actually focusing on identifying how data is defined and stored in its various formats. We're also going to focus on characteristics of relational and non-relational data. We will describe and differentiate how the data workloads are going to be stored. And then we are also going to describe and differentiate batch and streaming data, because we need to see how the stream processing and the batch processing is happening with the data. Let's start with what is data. Well, the definition says that data is nothing but a collection of facts, number, descriptions, objects stored in a structured, semi-structured, or maybe unstructured way. And as this definition says, this shows me that data can be stored in various formats actually. So it can be structured, semi-structured, and unstructured. If you have ever dealt with the data which is something like a notes or some kind of a file system or some kind of a notepad file, then you can count it like that data is something which is fully unstructured. Even the data which is in the form of images and videos are also coming under the unstructured data format studio. Same way, in spite of this unstructured way, suppose if you go with the little bit more organized way, then it will be semi-structured data, where the data is going to be stored in a form of key value pair. And as visible on the screen, semi-structured data is going to have this kind of key value pair kind of data stored, which is not fully structured, but still we can understand what kind of data we have stored in that. And now if you want to go with the proper tabular data, where the row and column kind of structure we are going to follow, we are also going to have things like primary key, foreign key, unique key kind of constraints. And if you are following the proper schema every time when you store the data, then that is going to be your structured data. Now when we talk about data, obviously where we are storing data is also equally important. And whenever you store data, we call that thing data store. It is important to understand the distinctions between OLTP and OLAP data, which normally I call OLAP. Now if you see, OLTP stands for online transactional processing, while OLAP stands for online analytical processing. In OLTP, data is stored one transaction at a time. Most of the time when you have any applications in which you have performed some data operations like inserting data or updating data, then that is something which is a transactional processing, and that data comes under OLTP data store. While there is another kind of data store which is OLAP. OLAP is an aggregated system. Data is most of the time imported from other OLTP systems and then aggregated. The aggregation will typically occur at the different levels. So there are chances that when you're storing data with OLAP data store, the aggregation is going to happen at different levels, and it allowing you to drill down or up for multiple levels. For example, you have a company summary to a department summary to maybe in a department particular employee summary is going to be there. When you drill down into next kind of level, then the further more detailed data you can get into that. Because OLAP data is aggregated periodically, once the aggregation has been performed, queries which we need to summarize that it contains are going to be very fast. So compared to OLTP, OLAP queries are going to be faster. Now if you ask me when we have to choose which data store, then I will say that OLAP is good for many but small updates that happen frequently, while OLAP is good for large summarized queries that happen periodically but not very frequently. Now after the data stores, we need to understand transactional workloads also. Transactional data is information that tracks the interactions related to an organization's activity. Now when you are focusing on this, you have to focus on 4 words which are atomicity, consistency, isolation, and durability. Formally, these four words are known as ACID properties. And I'm sure if you are somehow a tech or IT person, then you have surely focused on these four words, or you have surely heard these four words earlier. That's the reason I'm not focusing on this ACID properties in depth right now. But yes, that is also something which is very important point to understand. After this transactional workload, this is somewhere which I want to focus. We have analytical workload. Obviously, transactional workload focus on OLTP, same way analytical workload focus on OLAP. Analytical workloads are typically read-only system that stores the vast volume of historical data or business metrics. Analytics can be based on a snapshot or maybe a data at a given point of time, or maybe a series of snapshots can be there. An example of analytical information is like a report or monthly sales or any particular data on which you want to perform some analytical operations, and then you want to generate some graph structures or some kind of historical reports based on that. Hey guys, sorry for interruption. My name is Maruti and I'm here to make a very important announcement. I hope you are liking our videos and you're doing a continuous learning with us on an Azure cloud and AI related topics. If you are enjoying this thing, I'm going to announce skilltech.club, which is our upcoming website, which is going to be launched very soon. We are here to tell you one thing, that everyone who is a subscriber of this particular channel will get Azure Cloud and Azure AI related certification courses free of cost in skilltech.club. So you will be a part of the skilltech.club kind of a membership automatically free of cost. And everyone who's a subscriber of this particular channel will get those benefits which are available in that. So what are you waiting for? I request you to please subscribe to this channel and share it with your friends and families if they are also interested in Azure Cloud and AI learning. That's it from my side. Now you can carry on with your learning. Thank you. After the workloads, now it's the time to understand data processing. Data processing is conversion of raw data to a meaningful information through a process. We know that we can store data from various data sources. Maybe you have a data which is stored from some server-side logs. Maybe you have some organizational servers running from couple of months and couple of years. Or maybe the data which is coming from some kind of devices like IoT devices or some machines which are running in the organization. Then those data is actually something which are actually raw data. Now when you have to process the data, you have two different kind of data processing: batch processing and stream processing. Batch processing is suitable for handling large data set efficiently. Stream processing is intended for individual records or something like a micro batches consisting of few records only. So when you have huge data, then you are going to focus on batch processing. When you have limited amount of data, then you can do with the stream processing. In batch processing, data elements are collected into a group and the whole group is then processed at a future time as a batch. So that's why we call it batch processing, because the all group is going to be keeping a batch of the data into that. In stream processing, each new piece of the data is processed when it arrives, and this is something like a live streaming of the data. Think about this, that you have some kind of a data which is streamed continuously as a video or as a price chart of the currency conversion, or maybe any latest stock market or cryptocurrency costing analysis which is continuously streaming from one end, and then you have to process it accordingly. The same way stream processing is there, where every new piece of data which is coming into the stream is going to be uploaded and then it's going to be further processed into that same pipeline. So after this, we need to understand latency, which is nothing but a time taken for the data to be received and processed into that. Comparatively, batch processing is actually going to have a latency of hours because the amount of data is going to be huge. And the stream processing is going to take comparatively lower latency, which is obviously going to be in seconds or milliseconds actually. So in this video, you have focused on the core data concepts, where you have learned that what type of data you have, like structured, semi-structured and unstructured data. We also focused on data stores, where transactional and analytical data stores can be there, where you can see that we have OLAP and OLTP. We also focused on the transactional and analytical workloads, and then you have understood batch processing and stream processing in data processing.